and then change our view. So thanks for hanging on, those of you who were out trying to watch for people coming in. This is our next to last TUG meeting for this spring. I think our last meeting is next week, in which time we may stretch a little further. Alice and I were talking. I don't think we've actually seen the exercise people come in here. So we have a little business to do at the meeting next week, electing officers for the next year. And our speaker will be talking about cutting the cord, and he may want a little extra time. So we may go a little late next week. This week, however, we had a little technical hiccup, but Claude Haynes is here with us now, almost live, but almost in person, but definitely live.
That's debatable.
And we've all gone out at one point or another away from town and looked up at the clear, starry sky and wonder. And one of the things I wondered is, what are all those constellations? And I can never get things straight. So I am particularly interested to listen to Claude today to talk a little bit about night skies and stargazing for those of us that don't know anything about it. So with that, I'll turn it over to you, Claude.
Okay, we're going to try sharing screens. And let's see if this works. So now, do you see a screen that says Skywatch?
We do.
And did it magically now say East Valley Astronomy Club?
It did.
All right, good. I think we're in business. Okay, we will pray to the computer gods that they will be happy. Generally, I'm a member of the East Valley Astronomy Club. As most organizations, our activities have been severely curtailed for the last year. And hopefully that will be taking care of itself soon. I've gotten all of my shots, so I'm now immune to anything that could possibly happen. And I would encourage everybody else to try for the same level, but we'll see. In addition to being a member of the East Valley Astronomy Club, I'm the manager of the Gilbert Rotary Centennial Observatory that's in the Riparian Preserve in Gilbert. It's next to the Southwest Regional Library, or Southeast Regional Library, at Greenfield and Guadalupe. We are normally open on Friday and Saturday nights for public viewing, but we have been closed for a year and continue to be closed. So please check our website. We hope to be opening sometime, but the board is still kind of working its way through to decide what would be the best action for us. And today I'm going to be talking to you about stargazing basics. Now, the topic today is going to be very broad and kind of far-reaching, and it's basically an overview of what it takes to get into looking at the sky and gazing at the night sky. And so if there are questions, let me know, or we'll at the end and kind of work our way through that. The first thing you need to have is dark adaptation. This is kind of a scary slide, but what you want is your iris to be as wide open as possible so that you can see as faintly, as faint as anything is in the dark sky. The way to do that is basically to get away from light. And as you can see from this mosaic from the International Space Station, we have a lot of light, especially on the East Coast. The West Coast isn't as bad, but you can certainly see the Phoenix, Tucson area here, and certainly the lovely LA Metroplex. And the brightest dot is going to be Las Vegas. So the issue is that you want to go to some place, if possible, where it is dark. Now, the problem is in town, you have a lot of lights like these, which are just bulbs that blast light out, and you have a lot of light trespass from your neighbors. You don't have to go to a place that's completely dark, but you want to let your eye dark adapt. So you would like to go to some place that is better than just in your backyard, especially if you have like mine, floodlights from my neighbor that shine into my yard. Uh, EVAC is a member of the International Dark Sky Association, and this is an example of good lighting. This is a sports field with lights that are targeted to shine directly on the field and not have a lot of stray light scattering out into the sky. And this helps with light pollution. Light pollution is one of the easiest things in forms of pollution to fix, because you just have to have some good uh, uh, fixtures to shine the light, or you just have to turn off some lights. And if you would like a good example of that, if you drive on the freeway, the 101, go past Tempe Marketplace, and you can look on one side, Tempe Marketplace, which is a riot of bad light, and the soccer stadium that has been built using light similar to this. And at night, you can see it's just lighting up the field. There's not a lot of stray light on that side of the field because they are using good fixtures. So that's one thing we would encourage is trying to avoid extra light. All of us carry dark adaptation denial devices in our pockets. Cell phones, if you stare at a cell phone, so people say they ask to go out, advice on going out to look at meteor showers or something. And the first thing I say is go someplace where it's reasonably dark, and then don't look at your cell phone for 10 minutes. Because if you're looking at your cell phone, even at when it is set for dark mode, it's not dark, it's white and blue light, and it does impact your eyesight. Now, the first thing you can do is look at the moon. And so if you're looking at nothing else, this is a wonderful thing to look at, and it changes throughout the month. Um, Starting, we just passed new moon. So we have small crescent moons. We're about this phase or so. It's the Cheshire moon. When I was looking last night, it looks like a Cheshire cat. And as you can see, as it goes toward full moon, the moon rises about 50 minutes later each night. And the full moon will be in a couple of weeks, and it will be at sunset. And the moon is always rising as the sun is setting. And in that way, as you watch the moon through the month, you see more and more of the moon illuminated. It's fun to look at, and it's just an easy thing to see. So if you don't observe anything else but the moon, that's a good start. Now, in looking at the moon and the way it works, it's tidally locked. So this is not to scale. The sun isn't this close. If it were, it would be even hotter in Phoenix. But at new moon, you can see the moon is closer to the sun than the Earth is, and we are illuminated by the sun, but the far side of the moon is illuminated. Uh, no offense to rock bands, but there is no dark side of the moon. The far side of the moon gets just as much light as any other part of the moon does during the course of the year. And as the moon orbits and creates one orbit of the Earth, it also creates one turn on its axis. So that being tidally locked means that the near side of the moon is always visible to us, and the far side of the moon is not. So we can't see the far side of the moon with our naked eyes. And as it rotates around, you will see it changes from a waxing crescent to first quarter, where half of the moon is illuminated, to waxing gibbous. Waxing is an old English word for growing. And at full moon, it's on the opposite side, and the sun illuminates the full moon fully. Within the next night, it's rising 50 minutes later, and less of the moon is illuminated, and less and less and less till we get back around to new moon. And that's how the process of the moon itself works. And it's always fun to watch that change in the face of the moon. And you can find easily, naked eye, the mare, the seas. This is Latin for seas. When they originally looked at it, they thought, well, these must be big lakes. So we'd have the Sea of Crisis and the Sea of Fertility. Here, the Sea of Tranquility, where the Apollo 11 landed. You have bright craters like Copernicus, Ptolemy, and Tycho that have those rays of ejecta that you see, and they're easy to discern because a big object hit the moon and it's scraped across the surface. And Aristarchus is the brightest crater. So if you're looking and you see a bright spot, that's going to be the crater Aristarchus. So looking at the moon is a really fun thing to do, and it doesn't require a lot of equipment. One thing might be a pair of binoculars. With binoculars, you can see some objects. Here's a image of the Pleiades, the seven sisters, that show up very, very well in binoculars, and they work great for terrestrial viewing. So you can visit the riparian uh, preserve and do bird watching. We're an Audubon site. Uh, if you're looking at binoculars, 1050 would be 10 is a magnification, 50 is the field of view. And if you're buying binoculars, check for clarity at the edges. You don't want to necessarily buy these off the internet because binoculars and other optical devices vary greatly sometimes with from unit to unit. Look for sharpness and ease of focus. If you're wearing glasses, like most of us old folks, check for eye relief because that sometimes will be an issue. And consider the weight. These are big binoculars with lots of power and a wide field of view, but they're going to be heavy, so they're going to be hard to hold. The best power for you would be 7 to 10 power and 30 to 50 field of view. These are image stabilized. I have a set of these. You press the button on the top and it kind of takes care of the handshake that's normal for humans. They're a bit pricey, but they're really very, very helpful in terms of stabilizing the image, making it much easier to see. I would recommend is going in the plant. This is a plastic or paper cardboard device and a red flashlight. And the red flashlight is helpful because it makes it easier for you to retain your dark adaptation. Our eyes respond less to red light. That's why you remember in the old days of photography, there were red lights as a person was developing the photographs because it did not impact the image and it doesn't impact our eyes as much. And the planisphere is an easy way for you to find where things are in the sky. It works very simply, but it's kind of awkward sometimes for people. Brad here in the middle is at the North Star, Polaris. And here you were looking straight south. To one side is the east, the other side is the west. And so as you're holding it, you would put it in front of you with east on your left side pointing south. And then you can look for the brightest dots, which would tell you the first magnitude stars. And you set it by putting the time and the date, and the sky pretty much is in that pattern throughout the year. And so it rotates through the fixed stars. We'll talk about being the term fixed in a minute because it's not really true. But this would let you then find where the major constellations are. You can look for the Milky Way with the blue band. You can find the bright named stars, and that gives you a way to find out where things are in the sky. The next thing might be to buy a book, which would help you with some of those. Night Watch is a very good one. They have various editions. I think this is a picture of the older one. And an easy one to use is The Stars by H.A. Rey. Some of you may remember the name because H.A. Rey was a cartoonist and he wrote the book Curious George. But he was an amateur astronomer and he was a friend of Einstein. And as such, he made star charts that look more like cartoon figure drawings, which make it easier for kids and even older folks to identify without some of the kind of strange drawings that you see in older pictures. This is kind of an easy, accessible book. It's been in publication since the 50s, maybe even the late 40s. And you can often find it at a used bookstore because it's very prevalent. And this would be a good one to start if you want to find out about celestial mechanics. It has a nice section in the back. and it also gives you some good clear star diagrams. Now, while most of you don't know much about astronomy, I bet all of you know what sun sign you were born under. And we have to admit that astronomy started with astrology, but broke off a few hundred years ago when it became apparent that astrology is a happenstance, not a science. Here we see the sun and the earth and the path of the earth through the year, and we have the constellations of the zodiac. And these are constellations that fall within what's called the ecliptic. This is the path of the sun, the moon, and the planets. And so you can see these various patterns. Gemini, drawn out this way, looks kind of like twins. Cancer doesn't look like a crab. Leo sort of looks like a lion. Um, it's really hard to say that Aries is a goat. So the choices of the stars and the constellations don't look very much like the object. I guess the closest is the Scorpion, which you can see the three stars and the pincers and the tail. This one is a little more representative. Pisces is two fish. It's just like a line of stars. Um, and so I think you find that a lot of people know these and can hopefully find those in the sky, but they just happen to be there. It's kind of like real estate: location, location, location. But those stars are prominent in the night. Most of them have at least one or two bright stars. Sorry if you're born under Cancer, there are no bright stars, and it's really kind of hard to see. Libra has two bright stars, which I love because they're Zubin Eshamali and Zubin El Janubi. They're Greek words, and they're just fun to say. I don't know what they would translate to. I can look that one up. But if you follow this, this at least gives you some idea of what the sky, where those are in the sky, and you can follow the paths of the ecliptic and find where the planets are. Now, a couple of terms that are helpful are altitude and azimuth. Altitude is up and down, azimuth is left and right. And so astronomers use this to determine where things are in the sky. And by using this altitude and azimuth, we can create what is in effect a map of the sky so that you can see where things are in their position, either in geometrically 5 hours, 55 minutes away from a line 0 that runs through Aries, or 7 degrees, 24 minutes. One is termed right ascension and declination. Um, and this gives you a way to find things like here, the constellation that a lot of people can easily recognize, Orion, with the three bright belt stars. This is pretty much overhead in the winter sky, and Sirius, the brightest star in the uh, winter sky. If you just follow down a line from the belt, you'll bump into Sirius or uh, Canis Minor, Procyon. So you can find easily, once you know where a few things are in the sky, you can follow the lines and path of those stars and find other things. The bright stars here, Betelgeuse and Rigel, are the two brightest stars. Bellatrix, Saiph, uh, are also bright stars. And so by finding a few bright stars and using the planisphere or a sky map, you can then hop over to find other places in the sky and other constellations. Now, I warned you about using cell phones. We use astronomy apps, and they have a night mode, which is red. I didn't copy these pictures because it's easier to see this way. Here, the application is called Sky Safari, but there are lots of others and some free ones that are very good. This one costs a little bit of money, but not tons. You can see where things are in the sky. If you clicked on a particular spot, like that shoulder star of Betelgeuse and Orion the Hunter that we talked about, you can see its various catalog numbers, a description. You can see its right ascension and declination, or its altitude and azimuth. And if you click on description, you can get details and pictures and more information. So a lot of times these astronomy apps are also a good way for you to learn where things are in the sky and learn more and more about the individual objects. When we're looking in the sky, most people would start looking at north, and Polaris is the North Star. It's pretty easy to find. If you have a compass and you know where north is, each fist at arm's length is about 10 degrees. So pointing at the horizon with your fist, 1, 2, 3, 4, just above your fist would be a bright star, and that would be Polaris. So it's an easy way to find the North Star. The Little Dipper is tagged to Polaris. The brighter stars of the asterism, the Big Dipper, that's part of Ursa Major, and those pointer stars point toward Polaris. And the upside down W or M in the sky, Cassiopeia, are also very prominent. So if you look in the north sky, it's easy to find those. Now, the Big Dipper and Cassiopeia are opposite each other. So as they rotate through the night, you may see Cassiopeia, you might not see the Big Dipper, and then the sky will rotate in this counterclockwise direction through the night. You have Cephas, the king who is husband of Cassiopeia. You have Draco the dragon. You have lots of things that are in the northern sky, so it's easy to see. Now, one of the reasons that we say that astrology is coincidental and astronomy is a science is that the sky isn't unchanging. The sky, everything in the universe moves. We're moving all the time. Our stars are moving, sometimes toward each other, sometimes away. Um, and the Earth, like a top, rotates on its axis. And that rotation creates something called precession. So right now, the pole star is Polaris. If we go back one and we look at this star, this is called Thuban, and this was a North Star thousands of years ago when the pyramids were built. So if you're watching the History Channel, or more likely named the Myth Channel, and you're hearing about all of those alignments, and you're seeing a modern day map and saying the pyramids all line up neatly with all of these things in the sky, they do now, but maybe they didn't then because of this factor called precession. Uh, the North Star will eventually become Vega. And for thousands of years, there will be no bright star near the North Pole. The Polaris is about a half degree away, so it's convenient for us in our lifetime. But thousands and thousands of years, there won't be a bright star near the North Pole itself. Um, when you're looking at those constellations, here we have the night sky in winter. We're kind of moving into spring, so the things over here on this side have already set by the time the sun sets, and you can see bright stars. You'll find overhead next to Taurus, the bright star Aldebaran as its eye. The Pleiades, the lovely seven sisters, it's easy to find as a naked eye cluster. You don't even need binoculars, but it looks better in binoculars. You'll find Sirius that we talked about, the eye of Canis Major. If you happen to have Sirius Radio, that's their logo. So it's easy to find where these things are, and you can hop from star to star by knowing where they are and then saying, oh, this bright star over here in this pattern, it becomes easier and easier to find where things are constellation-wise in the sky. The hardest part is when you go to a dark sky site and you see a lot more stars. Sometimes these stars in Cassiopeia is always pretty visible, but some of these others, because they may have only one bright star and might be close to something else, they get harder and harder to find because there are just so many stars in the nighttime sky. Here we see a later time in the summer where we have Leo and Virgo and Libra following this line of the ecliptic. Uh, and Leo is fairly easy to find with a kind of a backward question mark forming its head and this bright triangular tail here. So it's easy to find. And as we said, the planets fall into that ecliptic. So the path through the zodiac is also where you would find planets who wander in and out of those constellations. And then here we have an image uh, of the summer, where we have Vega, Deneb, and Altair forming what's called the summer triangle of three really bright stars. You have Sagittarius and Scorpio, and Antares, the bright heart of the scorpion, the tail, and it's easy to see. And the Milky Way will be going right through this path up toward Hercules with the bright cluster M13 in there. Sorry. Um, Everybody, if you go out to a dark sky, especially in the summer, the winter, we're looking out away from, sorry, the center of the galaxy. But in the summer, you'll see the Scorpion and Sagittarius, and then this bright spot here is the center of the Milky Way galaxy, and with the Milky Way arcing overhead. Now, in March, we would go out as astronomers normally to have the Messier Marathon. And I'm going to apologize. I'm going to go grab a quick drink of water, chat among yourselves, and I'll be right back.
We were talking about streaming earlier. I'm just getting into using my Fire Stick. This is Chuck. Can I get on my Gmail account from my Fire Stick? Anybody know?
I have not successfully done that. I have seen some apps that you have to set up on your Fire Stick to be able to access some of those kind of sites. Um,
Okay, sorry, thank you. Now with a little water, maybe I'll stop coughing so much. Charles Messier was a French comet hunter. He was the last royal astronomer of France. And he looked for comets, which were fuzzy things in the sky, because his telescope was not huge. It was like a 6 to 8 inch telescope, depending on which one he used. And he was in the Hotel Cluny in Paris, which didn't have a lot of lights, but it did have smoke. It did have things that would obscure the sky, and it had clouds. So he made a list of 110 things you didn't want to look at. They weren't comets. And so this is what most astronomers start with. And the Messier Marathon has nothing to do with running. If you find my body next to a jogging trail, that is not where the murder took place. But it is a chance from sunset to sunrise to look at the sky, and through the course of the night in March at the new moon, you can find all 110 objects. And so it's a contest to see how many you can find. And I've found 109, which was the most available. Sometimes, depending upon the time of year, how far into the month, the first one or the last one. So in the sunset, something might be lost, or in sunrise, something might be lost. So you may not get all 110. But I found all that were available, and it's a fun project. So the Messier Marathon is something we would normally do. Unfortunately, this year it's canceled again. But I know some folks who are going to go out and observe anyway this coming weekend, which will be the new moon. Here you'll see the image of the Milky Way, the Scorpion, and in the tail of the Scorpion, and this little teapot asterism, which is part of Sagittarius, the Archer, you will see this little bright spot here, which is the center of the galaxy, this little puff of steam coming out of the teapot. And you'll see M8, M25 on your planisphere or other charts. You'll see these Messier objects. Here is the Sagittarius star cloud. It's a fuzzy spot because what you're really looking at is millions of stars headed right toward the core of the galaxy. And you'll see New General Catalog, NGC, or international catalog, you'll see some other things that aren't included in the Messier list, but that are interesting to see, like an open cluster here or a different cluster there, a grouping of stars that happen to be in a small field of view spot in the sky. M8, the Lagoon Nebula, you can see it kind of glowing brightly in the photograph. These are fun things to find in the sky. So I'm going to pause for a second. I don't know if folks, Scott, can they send in questions? Have you seen questions, or does anybody have any questions so far?
We have not. Some of you may or may not know you can type your questions under chat. You can use a little raise hand thing to let us know you want to ask a question. Or because it's a relatively small group, I think we're at 6 participants. You could unmute yourself and at appropriate time ask a question, but I haven't seen anything pop up yet.
Okay. Well, if there are questions, we'll handle those at the end too. The next step is we get a lot of questions about what telescope should I buy? And the answer is you should buy one, but I can't tell you which one. And the best advice I give is to take a test drive. So if you check the website for the East Valley Astronomy Club, and when we go back into operation, we often have public star parties, and we will have people in the club come and bring their telescope, and you can look through it. And that gives you a way to look through a variety of telescopes, and then it makes it easier for you to possibly decide what telescope you want. There are basically 3 types of telescopes. There's the traditional refractor, which has light coming through a lens or a series of lenses, and they're focusing to the end, which is where the eyepiece is mounted, either directly or this with a diagonal, and you're able to look straight through the telescope. Sometimes on older professional, we don't have to wear a wainscot to observe, but you would have these long, large telescopes that have a very large lens in them. And so that makes it hard to use and limits its possibilities. A refractor does give you the sharpest image. It certainly has the fewest parts in terms of things to go wrong. You can use it as a terrestrial scope. There are 2 different types. There's an achromat, and which is the original kind of design, and an apachromat, which has some extra lenses in it. And the problem with the achromats is that you will have chromatic aberration. You've seen when something really bright and sparkly, you will get some fringing around the star, and it'll look like a rainbow. And the apachromat is a little more expensive, but the extra lenses keep that from happening. A 90 millimeter would be the minimum size I would recommend, which would be the aperture here. And the mount is important, and we'll talk about the mounts in a minute because there are a variety of types. But the refractor is the first type. The second is a reflector, and this is a simple telescope. It's often called a Newtonian because it was developed by Isaac Newton. Light comes in, hits a mirror instead of a lens, bounces back to a secondary mirror at a 45-degree angle and out the side toward your eye, and that's where the eyepiece is. The secondary mirror may require some collimation to get the best view. So it does have a little maintenance involved with that, but the advantage of this is you don't have chromatic aberration. You can get a bigger and bigger mirror. I have a 16-inch Dob. My friend Don just bought a 20-inch. So if you want aperture fever, it's easy to do with a reflector. This is a Dobsonian mount named for John Dobson, who was kind of a very unusual character, died a few years ago. This is more like a mortar, but you can take and use this to change the altitude, the up and down, and the azimuth, and it's a push-to mount. Here you have a reflector on an equatorial mount. We'll talk about the mounts in a minute, but it's a very, very easy design and very functional design. The third type, or here, let me finish here. This is best for aperture because it's the best value, simple design, It can be bulky, but and it will need some collimation of the mirror to make sure you get the best image. It's usually a push to, but by putting a motor down here and here, you can have it set as a go-to, and we'll talk about that in just a minute. But there are a variety of mounts that you can use. But the Newtonian is a great way to start. I started with a 10-inch Dob just like this, and it's a really, really good way to get started. And they're not that expensive, about $500, maybe even a little less for a set to get going. Now, the next type is the third type is called a Cassegrain, and it can be a Schmidt, Maxutov, Ritchie-Creation. There are various sub designs of this. But the light comes in through a corrector plate, a glass plate that focuses light onto the mirror. It hits the mirror, bounces back to the secondary, so you have a primary and a secondary, then down a tube to your eye. And this is the type that most amateur astronomers end up with because it gives you a very good package, and it's the design that most large professional telescopes like on Kitt Peak or Mount Graham, the large binocular telescope, they are a form of a Cassegrain design with a very large mirror, secondary, and then it can send the light down, not necessarily to eye because they don't have eyepieces, but they'll have cameras, or you can split it out to spectrographs, all sorts of different things in a professional uh, observatory. This is a more compact design so that you're getting less length that you then would be required by the Newtonian. It's robust, it is more expensive, but it's the best general purpose telescope, and it is the best for beginning go-to types of telescopes. Now, the object themselves will change the way you see things. So looking through refractor, you would see things as they are. Through a reflector, it would turn it upside down. Through a Cassegrain, it turns it upside down and backwards. So that makes, you have to just get used to that, but it does invert the image, especially if you're using a diagonal to now not look directly through the telescope, but turn it 90 degrees. Um, there are various types of mount. You have an alt-as is the simplest, where you're going up and down and around. Using these fine motion controls, you can control it easily. So the simplest design of an alt-as is that you may be used to is a tripod for a camera. By turning the crank, you can raise it and then spin it and tighten down. The problem is without the fine motion control, it's really hard to focus in on where you are. So cheap telescopes that have just an alt-as up and down motion, but without the fine motor controls, are going to be harder to use. Here we have an equatorial where you align the telescope to the North Star, and then you kind of balance it with this weight. And then after you have set your latitude and longitude, it will then let you swing through the motion very smoothly, more so than the ratcheting up and down, up and over that you get with an alt-as. You get a smooth swing. So this works better for photography as an equatorial mount. The other type is an alt-as with go-to. Now, a go-to takes the idea that we had from the Sky Safari, which is you know where things in the sky are on a coordinated grid, and the computer will let you then move to that location once you have properly aligned it to a couple of stars. So you align it on a couple of bright stars, you then punch the button, and it will take you to where the object should be in the sky. There are advantages and disadvantages to each of these. The single fork alt-as or the dual fork, this is designed for larger telescopes. Smaller telescopes may work off of a single fork. The alt-as is an up and over, so it's kind of a stair step. The equatorial, here we see a very large telescope with a lot of weights and go-to, would be the best if you're taking long photographs with your camera, because you will get a smooth motion and it will center on the object more uh, for a longer period of time. But all of the telescopes require eyepieces. So every astronomer I know owns
Wow.
several telescopes, and they own a pile, usually not this addictively large, but every eyepiece has an advantage in terms of its power or its size. And the size of the eyepiece is its output here. Um, the Kellner is an old-fashioned and has like a 0.95, which is a 1950s style of eyepiece. That is no longer the standard, so I wouldn't recommend buying one if it says the eyepiece is a 0.95. But you will sometimes find that on very inexpensive telescopes. The Plossl is the most common with a multiple lens arrangement, uh, and then the Naglers or similar designs, which are much larger and have a much more complicated form of lens in their path. They give you a very sharp image, and they can give you a great deal of clarity. There are two major sizes, an inch and a quarter and 2 inch. And this is just the difference in the diameter of the eyepiece. A 2 inch eyepiece will give you a wider field of view. So it's like the difference between watching television on your tablet and watching on your widescreen TV. A 2 inch eyepiece just gives you a wide field view of the sky, and it makes it a lot easier to see clearly with a larger image rather than a smaller image in the inch and a quarter. In addition to eyepieces, you may have filters. For eyepieces, the higher number, like a 24 or a that's an easy wide field, or 32, is a lower power and a wider field of view. An 8 would be a lower number, but it has magnification and is a narrow field of view. One of the biggest problems people have sometimes starting out is they go for the magnification. So they're looking for something and they will put in a low number eyepiece and then complain that they can't find what they're looking for. And the reason is it's there, it's just slightly out of view when you would find it with this higher number in a wider field of view. So the wider field of view lets you see a bigger piece of the sky. And then if you want to increase the magnification by going to a lower number eyepiece, you'll then get more magnification, but that does change the circle of view, the field that you're looking at. A Barlow lens multiplies the power usually 2 or 3 times. And then the filters, there are filters for color to make it easier to see planets, the moon to especially block out some of the brightness of a full moon so you don't feel like you're blinding yourself. Nebula filters like oxygen or sodium filters will show you clouds in the sky more clearly. And then there are light pollution filters that will kind of give you a greenish glow, but will block out some of the excess light and the lines from the sodium and mercury vapor lights that are in use around the cities. The next thing after eyepieces and the telescope would be to find a finder scope. There are optical finders and there are red dot finders. Now, the optical finder works like it would for a spotting scope on a rifle. You've got a crosshair. This will give you some magnification, and you want to get what's in the middle of the finder scope to be in the middle of the eyepiece of the telescope, and that is the way that you would then be able to go to a bright star and then look in the eyepiece and say, that's the bright star. You know which one you're looking at. The red dot is more like a heads-up display. It may have different images in the red dot. It has no magnification. So this is useful if you're just going to find a spot in the sky. This is more useful if you want to find something that's faint, like a Messier object, and you want to see a little more clearly what it is in the sky, and then a better image in your main uh, field of view in your main eyepiece. The telescope basics are, if you're buying a telescope, first look for a sturdy mount. things that are thin, like tripods for a camera, just aren't sturdy enough to hold the weight of a telescope. And the worst thing you want to have is have it move and then the eyepiece go wackada, 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 vibrating for a while. And you have to wait for things to be stable, or as soon as you touch it, the mount isn't sturdy enough to support it, so the image just gets wiggly. Smooth operation for the telescope and the focuser. Aperture beats power. So if you're looking at a telescope and it says magnifies up to 500 times, they're probably hiding the fact that it's a tiny little eyepiece, a little aperture, so that you won't get much light. And the purpose of a telescope is to gather light. It's a light bucket. So the more light you gather, the larger the aperture, the brighter the image, the clearer the image, the sharper the image will be. So you want aperture, not just power. 1.25 inch or 2 inches, 2-inch eyepiece will let you get a multitude of eyepieces. So sometimes having a reasonable telescope with several good eyepieces will give you more benefit uh, than having a larger scope, but a very limited supply of eyepieces. An adjustable finder scope, push to versus go to. Push to would be you control where the telescope goes. So the Dobsonian that we talked about, you would take the edge of the telescope, you would follow the with the finder scope, you would move it where you want to look, and then you would look into the main eyepiece. It does not track, so planets or stars would eventually move out of the field of view, especially if you're at high magnification. But if you know where things are in the sky, push to is very inexpensive. It's very reliable. You're not dependent upon batteries or cables or anything, and it's a great way to learn the sky. Now with GoTo and modern computer technology, though, um, GoTo is a very easy system, and oftentimes on some of the smaller telescopes from Meade or Orion or Celestron, you can spend $500-600 and get a good, reasonable 4 or 5 inch uh, Maxitov and a GoTo, and it's a great portable telescope, great views. The key is that you have to align the telescope. So if you don't have a good alignment, uh, the equatorial or the GoTo are not going to work for you because you're pointing in the wrong spot in the sky. And as it moves, it's going to move to the wrong place in the sky. And weight and time. So a lot of times I've seen people who are retired, they will go out and they will buy a big telescope. And then they realize that they are getting older and it's harder to carry. So it doesn't get as much use as it should. So weight and setup time are also an important factor, and it's why folks like me I own 6 telescopes. Sorry, I it's part of a 12-step program. I admit to that. It is an addiction, but the reason is that the refractor is great for double stars. It's great for open clusters. My 10-inch LX200 is great for planetary and for looking at higher magnification. And the other types of telescopes that you have, it's just the size and varies. My 16-inch Dob is great, but it takes some time to set up. So the general givens, if you're looking at an inexpensive telescope, the picture on the outside of the box was not taken using the telescope that is inside the box. So if you have a lot of beautiful images of the Horsehead Nebula, that's not what you're going to see through the telescope. Sorry, that's a photograph. You might be able to make it with that, but it's not what it's going to look like for you. It's like most things in life, you will have enough equipment to get started, but not enough to be satisfied. So the comparison here would be like fishing. A rod, a reel, a line, and a hook may be all you need to fish. But if you really want to fish, you do need that bass boat and the Dodge pickup to drive it to your house and cabin by the lake. So that's where you could really do fishing. And that's kind of what the issue with telescopes is, that we always end up with a lot more telescopes. The planet names are Latin, moons are Greek, stars are Arabic. Don't expect the manual to be in English. Now, this isn't a joke about Chinglish, which is some odd translations of the manual. We've talked about a lot of terms today: altitude, azimuth, declination, things that are not normally familiar to you. And it will take you a while to go through the manual. But really reading the manual and not just being a guy and saying, oh, I can figure this out, it really will help you to make it a better experience. The manual will let you know where things are, how to operate the telescope. And every telescope takes time, patience, and persistence, but it is worth it because you will learn a great deal as you go along. We've talked about a lot of various things here, and it's not something you would learn quickly. But if you join the East Valley Astronomy Club and you find some buddies to go out and observe the night sky, you will easily learn how to operate the telescope. You'll easily learn where things are in the sky. And it's really, really a wonderful thing to see the beauty of nature's art gallery. A comparison from a friend of mine was that it really is like looking at an art gallery. I'm never going to be able to own a Van Gogh. But if I go to MoMA and I'm in New York standing in front of that beautiful, famous portrait or picture by Van Gogh, I can see his brushstroke. I can see how he layered on the paint and the intaglio. That's something I'm not going to get in just a picture. And so while there are beautiful things and beautiful pictures on the internet from the Hubble Space Telescope, being able to go out and look at those things yourself is really, really very exciting and rewarding. Finally, just a few good ideas. Read the manual, check the website for videos. There are lots of videos from the manufacturers of telescopes. Practice during the day. Don't look at the sun unless you have a special telescope to look at the sun. But it lets you find how to operate the system. And the worst thing is going to be to have that little tiny screw that holds everything together fall into the grass in the dark, and you can't get things put together. So practicing during the day is a good idea. Have some spare batteries. Don't store them in the telescope. They'll leak. Doesn't matter. Start with the lowest power and the brightest object. So if you're aligning your telescope and you set it up and you then slew to the moon and you don't have the moon in the eyepiece, you don't have a good alignment. And that is the easiest thing. Start with the moon. Don't try to find the tiniest little nebula. Go and start with something big and learn how to use the equipment that way. Pack carefully, a case of good investment. And don't rush. There's a lot to see. So don't be in such a hurry that you fail to enjoy the moment. And a lot of times, if I'm using the idea of the Messier Marathon or what we tell people when they visit the observatory, don't just look at the center. Don't just look at the bright star. Look at all the things around it. You'll find different colors. You'll find different sizes, different brightnesses. There are lots of things to see if you're willing to look. And finally, the only bad telescope is the one that is never used. We get a lot of telescopes from family members who Uncle Fred has passed away, and they don't really know what to do with the telescope equipment. And so we end up getting it donated. And when we're actually having meetings once or twice a year, we'll have a sale of used equipment, and you can pick up some good bargains there. Finally, one is laser pointers. These are not toys. If you point one toward a plane, you can blind the pilot temporarily, and the FCC will be happy to charge you $10,000. And it is an impact on astronomy for us as well. So please avoid using laser pointers. At the Southwest Regional Library, or Southeast, I used the wrong one. We have some small 4.5-inch Dobsonians. We have some binoculars that we have donated as a club to the library. So if you're going to the library next to the Riparian Preserve at Greenfield and Guadalupe, I don't know that they are currently checking things out because they weren't for a while, but you can check and see if it's available. But you can get binoculars or a telescope, and they come with some books that we've included to give you a way to start out. So if you want to test drive, that's an easy way for you to do that. I also would recommend going out to the East Valley Astronomy website or the GRCO, Gilbert Rotary Centennial Observatory website, or our Facebook page for EVAC or GRCO, and you'll find some good information, hints and tips, and It's a fun club to be a member of. And finally, just take advantage of Arizona. We live in one of the best places for astronomy. That's why we have so many telescopes around the area, and why we have so much research at our institutions. U of A has a great astronomy department and optics department. They're managing the mission to Bennu, where they've captured some dust from the asteroid, and it's being sent back now to Earth. It'll land in a few years. ASU as well, it's managing a mission to Psyche. It's managed by Lindy Elkins Tompkins, who is one of the few women to lead a NASA space mission. They're going to look at an iron-rich meteor or asteroid, iron-rich asteroid Psyche, and then study it, which is different from the rocky asteroid, the stony asteroid of Bennu. Uh, Northern Arizona University, in conjunction with Lowell Observatory and Flagstaff. They have great programs, and I would recommend if you're going up to Lowell, it's a great place to visit. You can look through the big Clark, the 24-inch refractor from Alvin Clark that Percival Lowell used. You can see the astrograph that Clyde Tombaugh used to find Pluto. They have a new outdoor place consolidated for viewing that they've just opened up. Check again their website. I don't know that they are open for public view, but when you visit Flagstaff, it's a great place to go and look at astronomy. But take the time, go out and look at the night sky. Go to a place like a state park or South Mountain or Ussery that are a little out of town and a little darker, but enjoy looking at the night sky. So at this point, any questions?
I did see we had one online from Judy that was curious about GPS uh, in astronomy.
Sure. So when we talked about the go-to mount, the some of the new mounts have GPS, so it knows where you are. You still generally have to align your telescope, but I have one that has GPS. And so if it's a star party and it's just sunset and it's not dark, I can set it up with the telescope pointed south. It sort of knows where things are. And if I know where what the bright object is that I see, like an early star like Sirius or a planet like Jupiter or Saturn that show up right at sunset, or especially the moon, I can just now manually adjust it. And I've kind of done a rough alignment. It's not the best way to do it, but the GPS knows where you are. And because it knows where you are and you have pointed to a specific position in that celestial grid that we talked about, then the telescope will function.
Okay. Are there other questions for Claude? I had one, the little stargazer or star guide, I see it was set for 30 to 40 degrees latitude. For those of us that live further north, are there,
Yes.
can you get the same thing but a different latitude?
Good catch. So you want to buy one for the latitude where you are. And oftentimes, Barnes & Noble or one of the bookstores, you can order it, but you do want to know, yes, there are different editions based upon your latitude. Good catch. Yeah.
Claude, this is Mike. A few years ago, I was at an auction here in Apache Junction, and they had an Orion Star Blaster 4.5. So I was able to get it for about $85. It had a 15 millimeter lens that came with it. I bought a 6 to give me a little bit more power. Can that be converted to a motorized mount so that you don't have to keep refocusing or realigning?
Possibly. What I would How many years ago did you buy it?
About 3.
Okay, that seems to be within the window of opportunity. So you might, and it was an Orion.
Yes.
So if you know the mount and you go to their website and you can chat with their folks who are very helpful, you might be able to buy an attachment that would motorize it. There are some, if it's an equatorial, and that's what I'm guessing it is, there are some that would let it track. So it may not give you go to, but it would be a battery powered clock drive, which basically then would let you move, it let the telescope move with the motion of the Earth. So it would keep the object kind of centered. So
Okay.
it is a possibility, but it's hard to say because some of them have that, some of them don't.
Yeah, I'm kind of torn between that and perhaps buying a little bit better scope than this. This is just the first time that I've gotten into astronomy, and I've enjoyed it. But yeah,
So what I would also recommend would be that you look at, even if it's not a big fancy one, but getting a 32 millimeter eyepiece, because starting out with the narrow field of view of the 15, it's going to make it hard for you to align or to find things. So a 32 millimeter or a 40, 42 will give you that wider field of view. So start with that and then move up. But without the wide field of view, you're only seeing a part of the image that the telescope can give you, and you're making it harder to operate the telescope with that smaller eyepiece. Make
yeah,
sense?
I see what you're saying because it's hard to. I've got a finder which I can align it, but I've also bought a Barlow that helps increase the magnification. But
Right. But again, without the wide field of view, it's going to be hard to align and find things. Then you can move up by adding the Barlow. And the Barlow, if you take a 32, you now have that. So you put the Barlow in and it's 2x Barlow. So now you've got about a 16.
16,
So
yeah.
you've got the Barlow gives you flexibility in with your eyepieces. So it's like getting an extra eyepiece for each one that you own.
So a 15 isn't enough to start.
It's really not. The 24 would be kind of a minimum for the wider field. And the reason I would say that is if you go out tonight and you look at it, you're 15, you're barely going to be able to get a full moon, and that's only a half degree.
Yes, that's true.
And so that's the problem, is that if you're going someplace and you're close but you're not quite there, that extra field of view to give you a full uh, degree or two in terms of seeing will make it much easier to operate.
Okay, thank you.
Well, Claude, I want to, on behalf of the technology user group here at Mesa Regal, thank you for sharing your expertise with us. I learned a lot. I think I was drinking out of a fire hose a little bit, but we'll catch up. Let everybody know later today they can find this presentation on our YouTube channel after I get it downloaded here and uploaded later today. And thanks again for tuning in. Next week, we are going to be having our final meeting for the year and talking about cutting the cord. I don't think that has anything to do with childbirth. It's something else. So.
One other question. Do these star books tell us where to find the planets? The planets are kind of interesting to watch also.
They are, but they won't tell you exactly where to find them. Planetas is the Greek word for wanderer, and that's what planets are. They wander through the sky, but they travel along that path, the ecliptic, which is the path of the sun. And so what I would say, if you wanted to look for where the planets were, you can go out to a website, Sky and Telescope has a good website, and it would show you where things are. And they will have the night sky, the week a weekly sky chart, and it usually will show you where the planets are for this time. But the planets themselves wander. The stars would be fixed, but as we said, they're not really fixed. Over the course of time, they will vary, but they are more fixed than the planets are. But that would
What was
give you a
that
good
website
do
again?
that. Sky and Telescope. And it's a good magazine if you're interested. Astronomy Magazine and Sky and Telescope are the two large magazine publishers in the US.
Claude, I have Astro Viewer app, and I found that very useful for finding things.
Right. Yeah, there are a lot of good apps, either for your computer or the phone that we talked about, that would also show you that. So it's easy to find with those too.
All right.
But
Well,
you're right,
thanks
planets
again,
are always
everybody.
fun.
Appreciate your participation. We'll see you again next week.